Hello and welcome to this course on Introduction to the Art of Software Project Management. Long before software came into existence, many other prominent industries were very successful and they thrived in their businesses. Manufacturing, shipping, transportation, construction, and so on are just some of the examples of these industries which have been an essential component of the global and regional economies around the world. Traditionally, these industries were managed by the most senior people. The most experienced employees in these industries were responsible for planning and execution of day-to-day activities. They used to strategize and come up with the tactical plan to get things done. The other employees below these senior managers used to carry out the orders in accordance with the policies and procedures laid down in the enterprise. This unstructured approach worked for some time, but as the enterprises grew larger and more complex, they felt the need to introduce more structure to the process. A need for systematic and streamlined processes was felt. All the processes, planning, and execution came to be known as project management, and the person responsible for implementing these processes was named a project manager. When the software industry came into existence, the concept of project management was already being practiced in these industries, but it was in a different format suited to the construction and manufacturing industry. The time-tested methodology from other industries was ported over to the software industry, but with some unique twists. This has since then evolved into a software-specific project management concept over the last 10 to 15 years. Initially, the same concept of project management as was implemented in manufacturing and construction industry was also applied to software industry as well. However, the advancement of technology and the specific needs of the software industry led to more sophisticated ways of managing these software projects. For example, software project managers came up with a well-known sequence of activities called the software project lifecycle. They started introducing specialized software project management tools. Formal usage of industry-accepted methodologies like Six Sigma, Lean, Agile became popular. Although these tools have their origins in the manufacturing industry, they were fine-tuned and modified to suit the software project environment. And also, since software industry started to build some specialized tools for itself, as project managers and engineers were adept at building new software tools, it was easy to build these tools using technology advancements of the software industry. If you've been in the software industry for any length of time, you may have experienced this process yourself. The project manager assigns specific activities to the software engineering teams, deadlines and milestones are agreed upon, and the tasks are completed within a specific time. Along the way, the team is also expected to send regular updates about the progress of the activities. In case of a delay, the project management team may intervene and course correct as needed. Sometimes the original activity that was assigned to the engineer may be modified and a new deadline may be set for you. The timelines which the team works towards is called the schedule. The progress update provided by the team is called the project status report. And when the work scope is modified due to delays or other reasons, it is called a change request in the project management jargon. The software industry is growing at a rapid pace today. In fact, it's arguably one of the fastest growing industries today. Due to the technology evolution, sophistication of the technology, cloud computing, machine learning, open source movement, and many other factors, the software projects are just growing in numbers. Not only in numbers, but in complexity as well. And obviously, to manage these projects, companies need capable and well-trained project managers. but there are not too many that are ready to take up the role of a software project manager just because they do not understand the concepts of well-managed software projects. In this course, we will take you through the nuances of project management. We will teach you the details about the different phases of the project management and the exact roles and responsibilities of the project manager to efficiently manage a software project. This course will equip you with enough knowledge to become a successful software manager. Moreover, in case you plan to get an industry-recognized certification like PMP, which is Project Management Professional, in the future, this course will significantly shorten the preparation time for such certifications, as by the end of this course, you would have a detailed understanding of the complete software project management concepts. We sincerely hope you will enjoy this course and find it useful in your career advancement towards becoming a software project manager. Software project management is becoming essential in today's fast-paced and complex information technology world. Software project managers are the most sought-after professionals because the entire success of the project relies on efficient and capable software project management. More and more software engineers want to become software project managers as they can control the entire project and the product, as well as to attain the natural progression into the management hierarchy in the IT world. The need for software project managers is increasing due to the complex nature of the technology that is constantly evolving in the recent days. The need for quick releases of software products has become essential due to the tough competition that has become the walk of life. We hope you enjoy this course and the information that we are going to share with you. Let's get going. Here's the course overview. These are the modules that we will cover in this course. We will begin with an introductory module about the essentials of software project management. This will get you familiar with some core terms and definitions. You will also learn the essential points needed to understand the project management concepts. In the next module, you will get familiar with the concepts of software project planning. This will help you understand how to do estimations and the important concept of critical path. In the module after that, we will take you through managing your software project team. Team management is essential in project management because every goal of the project execution is achieved through the project team, and keeping them motivated plays a critical role in the success of the project. In the next module, we will discuss the quality assurance methodologies and how to actually make them work for the software project. This module will also help you undirect making test plans and the different types of testing. And by now, we would have come to the last part of the software project management. And in this module, we will understand how to formally complete a project by executing the software project closure formalities. You will get to know how to perform project postmortem and its benefits. In light of the course overview, what can you actually expect to take away from this course? Well, by the end of this course, you will be equipped with enough information about the essentials of software project management, the concepts, methodologies, challenges, tools. You'll get familiar with the various phases of the software project management, like software project initiation to software project closure, which are the two ends of the software project. You will learn the entire workflow a software project manager must follow to successfully execute a software project. You will also understand how you can efficiently and effectively manage your team. You will learn about quality assurance techniques, types of testing, and importance of testing. And last but by no means the least, this course will be a right step towards enabling you to become a software project manager from your current role of software engineer. This will be a very important and natural progression for you to get into the management hierarchy in your organization. As software project managers are the ones much sought after in the software industry, the more you understand the concepts and nuances of software project management, the more marketable you will be. let's get going. Let's get a preview into the overall gamut of software project management in a gist. Let's see why one may want to plan in a software project management environment. As you know, for any successful activity, planning is very important. In the same way, in a software project management environment, planning is extremely important. This is the phase in which the entire project management gets its initial shape, and this shape remains in focus throughout the entire project management lifecycle. A critical aspect of project planning is the initial estimations. As the word estimations implies, it's just an approximation of what is needed for the project concerning timelines, efforts, and cost. These three parameters become a triangle of constraints for a project. Hence, these are to be properly handled for the successful execution of the project. Once the project is planned well, the next obvious phase will be project execution. The software environment has many complexities, and hence the execution phase has to go through a lot of challenges and hurdles before coming out with the final project outcome, which could be a software product, a service, or some other artifact. Some of the challenges involved in execution are proper planning and managing the risks, managing the project team, and keeping them motivated throughout the execution of the project, monitoring and controlling the various metric parameters of the project, testing the software components, and finally, delivering the product. Each one of these topics is a huge discussion in its own right, and we will cover all of it in the upcoming modules. Project completion is as important as project planning and project execution in the software project management lifecycle. Project completion has very important and specific components. The completion of project deliverables is planned and agreed upon during the project planning phase. Some project completion activities include releasing the resources to the customers, documenting the success stories of the project, and finally, doing a software project postmortem to understand the learnings from the project. This entire set of activities formally completes a project. After project completion, there is still one last step to go through, which is formally signing off on the project outcome by the project sponsors. Without this important step, the project is not considered fully closed. Due to the benefits we discussed and many other aspects of a structured software project management concepts, companies across the world are embracing structured software project management processes. Needless to say, with many more efficient software project managers needed, the significance of the concepts of software project management is here to stay. Before we get going, let's talk about some housekeeping items. To download all the resources used in this course, please navigate to http://go.tetranoodle.com/software-pm. Here you'll find the slides and other supplemental material for this course. So if you haven't done that already, please navigate to the URL listed above and download all the resources to your local machine. Once you have downloaded the slides for this course, you can review them from your local system even when you're offline. As you've already seen in the course overview, this course aims to provide you with all the concepts of project management end to end. We hope you enjoy the information shared in this course and find it useful in your aspirations to become a software project manager. See you in the next module, where we will introduce you to the essentials of software project management. Hello and welcome to this module, the essentials of software project management. Software project management is becoming essential in today's fast-paced and complex information technology world. Software project managers are the most sought after professionals in the industry because successful execution and completion of each project heavily relies on competent project management. More and more software engineers want to become software project managers as they can control the entire project and the product, as well as attain the natural progression into the management hierarchy in the IT world. In this module, we will take you through the basics of software project management. You will understand some important terms about software project management and will also understand what it takes to become a project manager. What kinds of activities that you may need to take up as a software project manager. Enjoy this module and use the information that we share while managing your software project. Let's get started. Here's the overview of the module and the topics that we will cover. We will start with a general introduction to a software project. You'll get familiar with some essential terms like project, portfolio, and program. These are fundamental terms that you need to understand in the software project management context. Then you will understand what does it take to be a software project manager. A software project manager has to take care of entire project execution, team management, risk and external dependency management, and a lot more. This module will explain all the activities a project manager normally handles. We'll also discuss how project management evolves into a large set of activities which converge to produce a software product at the end and explain the different types of scenarios of a software project. We will then move on to the concept of the famous triple constraint in the software project management. You will understand how a project manager has to ensure the success of the project while working with these constraints. This set of constraints has to be managed through the entire project execution. We will then move on to see what are the success factors as per a research report by Chaos. You will also get familiar with two major software project execution methodologies, namely Waterfall and Agile, and their differences. Let's start with the basic definition of a project. A project is a temporary set of activities carried out to create a unique product or service. At the end of a successful project completion, the project team should have produced a product or a service as per the specifications laid down by the stakeholders or sponsors of the project. And by the way, this definition does not only apply to software project management, rather this is a generic definition which applies to any project irrespective of the industry. We call this set of activities temporary because the project has to have a specific start and a particular end date. Can't really go on forever. We will also define the product or services as unique because every project or service will result in resolving a specific problem. The project is designed and executed precisely to solve that specific problem. Let's now extend this definition to a software project, which is the context of this course. A software project is a set of activities at the end of which there will be a specific software product or a particular software service. The software product could provide any functionality or may be targeted at a certain industry like finance, insurance, healthcare, banking, and so on. The same applies to the software service as well. For example, it could be an application software that helps a company manage all their employees, different functions like HR, finances, and so on. This software is developed through a project with a defined set of activities. Now let's move on and extend these concepts and understand what is a portfolio and program and how they are related to a project. When you combine a few projects or programs, that are connected through a specific strategy or a common solution to a problem, then it's called a portfolio. Therefore, a portfolio is a collection of projects and programs. You must have heard people talking about, say, a telecom portfolio, insurance portfolio, and so on. And now you know what a portfolio is. Similarly, a program is a similar set of projects that have a common goal and normally the same set of resources deployed into the projects constituting the program. Hence, you can say a program is a large project with a number of smaller component projects. So in this structure, generally each of these projects is owned by a project manager and the whole program is managed by a program manager. And now let's quickly recap the definition of a project. A project is the smallest unit in the gamut of the software environment. Project is the basic entity for transforming the product into programs and portfolios. So to summarize, project is the smallest unit, a group of projects is a program, and a group of programs is a portfolio. To depict this pictorially, let's view them as in this diagram. The project is the lowest entity. The program is a larger entity comprising of one or more projects. The portfolio is the largest entity comprising of one or more programs. The yellow dot here represents the software or IT engineer. When you become a successful project manager in your discipline, you don't need to stop there. As you complete more and more projects successfully, you naturally have a better probability to move forward and become a program manager or a portfolio manager, handling huge strategic responsibilities in an organization. Now, let's review the essential responsibilities and activities that a software project manager carries out. First and foremost, a project manager is responsible for the planning. The project manager looks at the entire set of activities, prioritizes them or sequences them one after the other based on a number of factors which we'll discuss shortly. Planning also takes into account the dependencies between activities and tasks. For example, one task or activity may impact another activity in the same project. Planning also involves making sure all the required resources are in place to be used at the right time. For example, if testing of a specific feature of the software is planned in about 3 months from now, the project manager has to plan for the availability of the test resources like the program, the server, and so on, so that when the project needs these resources, they're available readily without any delays. The more the project manager focuses on the planning activities, the more efficient will be the project execution. The next responsibility of a project manager is naturally the execution of the planned activities. Execution of a software project, whether small or large, could become a complex process. You will see the different aspects of planning and execution in the forthcoming modules of this course. We've already defined the term project. During a project execution, there is an initiation of the project, which is the beginning of the project, and a closure, which is the end of the project. Moving on, let's understand the infamous term, the triple constraint in software project management. The overall quality of the project depends on the scope of the project, the time needed to execute the entire project, and the cost of the project. Continuing on with the triple constraint, projects must meet the agreed scope. Many projects fail on this constraint because the scope of the project is either not fully defined or understood from the start. When you keep changing or increasing a project's scope, you will either have to increase its cost or time. However, the cost and timelines are also generally agreed upon in the beginning of the project. These tend to have limited wiggle room because of budget constraints and the expectations of stakeholders. Hence, you can only accommodate a certain amount of scope changes in the project without exceeding the timelines or the agreed cost. Needless to say, in any mature software project, you'll still need to maintain a respectable level of quality. And of course, projects must be delivered within budget and expected costs. All projects have a finite budget. The customers are willing to spend a certain amount of money for delivery of a new product or service. If your project cost overruns the original estimates, that may put your entire project in jeopardy. Many software projects fail and do not see the light of day due to cost and budget overruns. The scope and the cost of the project go hand in hand. If you increase the scope of the project, the cost tends to rise and vice versa. So the cost dictates how much scope you can accept and remain within the timelines. The quality still needs to remain high. Projects must also be delivered within the agreed timelines. Remember the definition? All projects have specific start and end dates, meaning the timelines are already set. You need to execute the project within the timelines. If the timelines change, it may impact the cost, which may not be acceptable. And as we said earlier, no customer or stakeholder is going to accept a low quality product. So the quality still needs to remain high. A successful project depends a lot on how the project manager manages the project. These are the findings of a recent research study conducted by Standish Group. They produced this report based on several projects they studied during this research. This table is to give you a view of different success factors in project management. Let's take a few of these to understand them better. For example, user involvement. As per this survey, user involvement has the maximum contribution to the project's success. Why? Unless the user interacts with the project team regularly, evaluates the requirements, prioritizes the features, and most importantly, provides timely feedback, it becomes difficult for the project manager and the team to assume the requirements and to design the software. Hence, user involvement is absolutely necessary, and needless to say, it tops the success criteria. Similarly, management support. It is crucial for the project team to have full support from the management and the sponsors of the project. Without this support, it becomes really difficult to complete the project on time within budget. For example, for successful completion of the project, say the team needs specific training on a particular technology or framework, similar to the training you're taking right now. In this case, the management should support the team by approving and financing such training. Otherwise, the team may need to spend a lot longer to understand the concepts themselves, thus increasing the risk of project execution. Similarly, the third success factor is clear requirements. If the requirements are not clear, the project team will have to assume many of the requirements and develop the product, which may not be up to the expectation of the end customer. These are the 3 top contributors to a successful project. Now, we will see the two commonly used software execution models across the IT industry. The first one is the Waterfall Model, which uses a sequential approach to execute the activities of the project. It starts with planning, followed by design, build, test, and deploy in a sequential manner. This means that all the activities will have to be executed one after the previous one is completed. This means that if there is a delay in any of the activities in this sequence, the rest of the chain of activities will be delayed, resulting in the delay of the overall project. The waterfall model was used for a long time in the software project execution, but the more efficient agile methodology has become popular now. Now we will see the second commonly used software execution model across the IT industry, the Agile methodology. What is Agile methodology? Well, just the word agile means this methodology is more agile and nimble than the waterfall model. This model uses a repeated cycle of activities: plan, do, check, and act. The cycles are called sprints. Practically, at the end of each of the sprints, there will be a usable product delivered to the customer. Hence, this model is very efficient in product development, as products can be delivered in short life cycles. Agile is widely used and has become one of the standard execution models where the software release cycles are required to be shorter. For instance, you may have experienced these days you get regular software updates for your favorite mobile apps or any other software that you use in your day-to-day life. This is possible because of the Agile methodology. This brings us to the end of this module. Let's recap what you learned in this module. First, you got introduced to some fundamental terms in the context of software project management. You then became familiar with various activities that a project manager carries out. You also got familiar with the triple constraints within which project managers need to work and deliver successful projects. Hello and welcome to this module, Software Project Planning. For a successful software project completion, planning is an extremely important phase. The plan of activities which is formed in the planning phase influences or directs the execution of the project activities and all the subsequent phases of the project. Planning helps you identify all the steps that need to be taken care of in the subsequent phases of the project. If the planning activities are done properly, there is a good probability that the whole project will succeed in achieving the objectives. In this module, we will take you through the process of software project planning and why it's important. In this module, we will discuss the process of software estimation. You'll also get familiar with the types of estimates and why it's important to estimate the work and time needed as part of the project planning. Estimation plays a key role in software project planning because the estimates determine the timelines allocated, team size approved, and the cost budgeted are enough for the project or not. We'll then move to the basics of effort estimation and how it's done, the work breakdown structure. This is the most common and easy way of estimating the effort required for the components of the project. We will then talk about how to manage the three important components of the project, namely schedule, effort, and cost. Each of these impact the project in its own way, and therefore it's important to understand them better. We will understand what a critical path is in a project environment. This is really important because this is the path that leads to the success or failure of the project. We will also understand how to manage critical path after we get to know what it is. Managing the tasks in the critical path is important to execute the project within the deadlines. These aspects form the core of software project planning. There are other ways of estimations like lines of code and function point methods. If we understand the core of estimations, then it becomes easy to explore different estimation methods. You may recall the triple constraints that we discussed in the previous modules. These triple constraints are the basic elements of the project estimation. These are effort estimation, schedule estimation, and cost estimation. Effort estimation is the estimation of the amount of work needed to complete the project. The effort also gives you the team size needed to execute the project. As you can see, the size of the team determines the cost of the project. So indirectly, the effort influences the cost as well. The schedule estimation is the estimation of the amount of time needed to complete the project. The timelines include all the activities involved in the execution of the project, like project planning, implementations, testing, and so on. A word of caution here, you also need to keep a watch on holidays, vacation plans for the team while estimating the timelines. Apart from these, there may be external dependencies that can impact the schedule. For example, if you need a server for testing activities, and if the delivery of the server is going to take 2 weeks, then that time also needs to be included in your estimate for timelines. The cost estimation is the amount of money needed to complete the project. While there is an independent cost estimation that takes into account the requirements, normal execution and operations of the project, both schedule and effort also play an indirect role in the cost estimation. For example, if there is an unexpected delay in the project execution, then it'll increase the cost. Similarly, if any of the activities take more effort than expected, then it will also impact the cost. These three parameters are extremely important as these determine the success of the project and also the quality of the deliverables. One of the most common and easiest ways of estimating the effort needed to execute the project is called work breakdown structure, or WBS method. As the name suggests, this method breaks the entire project into smaller pieces of tasks so that we can easily estimate how much of effort is needed to complete the smaller pieces of the project and then add them up to get the estimate of the full project. The work breakdown structure not only helps you to estimate the efforts, but it also helps you to understand the requirements better. When you break the different phases into understandable pieces of work, you also get to know the details of what exactly has to be done to complete that particular activity. So, in case you do not understand some of the tasks or activities, you can get the necessary clarifications from the relevant stakeholder and understand them better. When we break down the work, the highest level of the structure, or the sum of all the lower level children tasks and activities, will give you the estimate for that phase of the project. The lowest level of these estimates is nothing but the estimate of the tasks or work packages. A work package is a set of tasks that are combined together to form a manageable component. For example, if executing a test case is a task, then configuring the setup, identifying the test results can be combined together to form a work package as complete a test case task. As the name suggests, Estimates are just approximate calculations or judgment of the value, number, quantity, or extent of work that needs to be done. Generally, this comes from the prior experience of team members. Estimations are not usually very accurate because you may need to make many assumptions wherever the activities or the requirements are not very clear. However, the decisions are made based on these assumptions so that we can proceed with the project. It's extremely important to document these assumptions so that when these assumptions change or they no longer hold true during the project, you can re-estimate the tasks based on the change in assumptions. Assumptions make the project teams go ahead with the decisions and not get blocked by some unknowns. Obviously, it's in the best interest of the project and the team if the estimates are as accurate as possible. The accuracy of the estimates depends on the nature of the assumptions, the level of detail with which the work has been broken down, and also on the skill and experience of the team members who came up with estimations. One of the good practices to follow during the estimation process is to get the estimates done by 2 different teams and then take a mean or average of the estimates for planning purposes. This reduces the biases which one team may have and generally leads to more accurate estimates. The next estimation is to determine how much time is needed to complete the project. The time needed to complete a project depends on multiple aspects: the availability of the team members, their skill levels, their vacation plans, availability of other resources like physical data centers, travel plans, and so on. Resource pattern is nothing but whether the resource is full-time, part-time, or on a contract basis. Usually, it's a good practice to keep a calendar of work hours for the human as well as non-human resources to keep a watch on the availability and track them. Estimates and other factors provide a basis to the project manager to come up with an acceptable timeline to complete the project. But sometimes, this calculated timeline may be too long or not acceptable for other reasons. Under those circumstances, the project manager has to take into account other means of completing the project within the specified time limits. For example, if the time is more important than the options available for the project manager are increasing the number of people on the team and thus the cost. If the project manager does not have the luxury of adding additional team members, then the options are either to decrease the scope of the project or to increase the productivity of existing people, or even doing few activities in parallel so that the project can be completed within the stipulated time. Cost estimation is another important factor of estimation of the project. Cost estimation is the likely cost of all the individual activities, and then they're summed up to get the overall cost of the project. The cost estimate has to take into account the cost of software development, testing, cost of infrastructure, cost of rework, cost of change in requirements, cost of quality, and so on. The cost is normally budgeted. If you recall the triple constraint, if the effort or timelines increase, it will automatically increase the cost. That's the main reason of any project being delayed. The effect is an increase in cost. So the budget is the initial estimate of the cost with assumptions on other parameters like schedule and effort. In spite of budgeting and estimations, any impact on the schedule and the effort or any other external factor will impact the cost, and hence cost has to be controlled. For instance, you may split the cost of some resources with other teams or even other organizations. You may opt to use outsourced resources for completion of the project while keeping the costs low. You may opt to use open source free software instead of enterprise grade expensive software. All these measures are part of cost control. There is also another aspect. The expected quality of the deliverables is directly proportional to the cost. That is why when we come across products that are of low quality, we can usually tell that they're usually cheap, whereas the products that are high quality are generally more expensive. Usually, the project manager estimates the cost and baselines it during the planning stage so that any increase in cost subsequently can be attributed to a specific factor in the project management. Most of the projects have an initial budget within which the project will have to be completed, and therefore the baseline is very important. One of the very important factors in project planning to understand is critical path. By definition, critical path is the activity or set of activities that take the longest duration of the entire project. These activities determine whether the project has a chance of overshooting the schedule or not. If the majority of the tasks and activities fall within the critical path, then the probability of the project extending the schedule is higher. The project manager needs to keep a watch on the number of activities that take a longer time and make sure that they're broken down into more manageable activities to control them more efficiently. There is another important term in the estimation process called stack. A stack is the amount of time an activity may have to wait until another activity is completed. For example, testing cannot start unless coding is completed. So the testing activity is directly impacted by any delay in the coding activity. The project manager has to ensure that all the interrelated activities are progressing without any delays in order to maintain the overall progress of the project. Critical path is extremely important for the project planning. As we discussed, any task or activity that is part of the critical path has the potential of delaying the entire project. Hence, the project manager has to pay extra attention to the tasks and activities that are falling within the critical path and shorten them so that it impacts the overall project schedules in a positive way. It may be possible that the activities in the critical path, due to their nature, may need more effort to complete. One of the common ways that an alert project manager may address this is to add a few more resources, to add more bandwidth to these activities. This is one way of managing the critical path, but as we know, increasing the team size will increase the project cost, and, well, this may not be the best solution. Another way is to look at the possibilities of increasing the productivity of the resources that are taking care of these activities, because adding the resources may increase the cost. For example, if this is a testing activity, the project manager may look for automating the process of executing the test cases instead of doing manual testing. This way, we may be able to avoid adding more people to the team and therefore control the cost as well. While focusing on the critical, if we don't focus on the non-critical path activities, then there is a good chance that they become critical and fall into the critical path. So it's essential to strike a balance between the critical path as well as the activities in the non-critical path. And that brings us to the end of this module. Let's recap what you learned. In this module, we discussed the process of software estimation at length. You got familiar with the types of estimates. You then understood how you could manage the three important components of the project, namely schedule, effort, and cost. Next, we discussed the critical path, which, as the name suggests, is very important for the completion of the project on time. Hello and welcome to this module, Software Project Team Management. A software project manager typically manages the project which is executed by a team. The team may consist of software engineers, IT engineers, designers, analysts, and so on. A motivated and competent team is one of the biggest factors which affect the final outcome of the project. Arguably, people and team management is one of the biggest challenges that project managers face. In this module, we will focus on understanding how to take care of your team. You will start with understanding the importance of teamwork and the different components of how a team works, interacts with each other, how a team's performance can be enhanced. We will then discuss the dynamics of the team and how to understand and take care of them. There are 4 specific levels of team dynamics, and the project manager should make the team move to the highest level of the team maturity through a popular team development model known as Tuckman's model. This will tell you what are the 4 maturity models of your team. Motivation is everything in teamwork. In the next topic, we will talk about how to motivate your team to perform at the highest levels for the project work. There's something called a need pyramid that describes what are the basics needs that are to be taken care of by the project manager to make sure the team is a successful one. You will understand the nuances of the need pyramid. And coming back to the topic of risks, there are also a few risks that are related to the team, and you'll get to know about them as well. These risks must be addressed by the project manager to efficiently handle the team dynamics. Do you know why teamwork is so important in a software project management environment? It's because there is hardly any non-trivial project which can be completed by a single person. Generally, software projects comprise of people from different disciplines like software engineering, IT management, design, business analysis, and so on. All these skills need to come together and contribute towards the success of the project. So within the context of a software project, it is implied that you have a project team executing the project. You as a project manager need to manage the team as part of the software project. Project management is all about managing this team effectively so that they're equipped to perform at their best possible potential. Inevitably, you will have people with different backgrounds, different experience and expertise levels. Every human being is different and unique in their own way. Everyone's objective is different, and it's the responsibility of the project manager to ensure that the team is always ready to support the project and make it a huge success. Apart from understanding these subtle points about the human capital of the team, the project manager has to track the responsibilities of the team to make continuous progress on the project. For this, the project manager must ensure that everyone in the project is equally balanced regarding their deliverables and responsibilities. Otherwise, you may end up with a lopsided allocation of work where one team member is overloaded with work while some others are sitting idle. Of course, everyone on the team should have the right skill sets and expertise to be able to deliver on their responsibilities. It is also important that the productivity level of every team member is at peak level to make sure that everyone is contributing positively to the progress of the project and their efforts are synergistic to the overall project effort. If someone's performing at a level lower than expected, the project manager must investigate and ensure there is no unmet need which is resulting in the underperformance. There may be simple issues like slow workstation, uncomfortable lighting, furniture, and the sun. Or probably the team member needs specific training to accomplish a specific task. So a candid discussion with the particular team member to understand the exact issue will definitely help. The project is successful only when everyone in the project is highly motivated, productive, and happy. Let's now look at the popular Tuckman's model of team development. Every team goes through a transformation of 4 stages: forming, storming, norming, and performing. Forming is the initial team formation stage. This is where the team needs more guidance from the project manager. Since the team is so new and multiple team members may be new to the organization itself, they may not even know each other very well. They may not know the details about their roles on that project. They may not know how to execute the tasks and activities in the project. It is the project manager's responsibility to make sure the team gets off to a good start. The team members must establish a professional rapport and get to know each other. Their roles and responsibilities must be clearly articulated to each team member. The rules, processes, and procedures must be clearly laid out so that each team member can deliver their tasks as per the expectation. Even unforeseen circumstances must be planned and articulated. For instance, the escalation processes must be clearly laid out so that team members can react and escalate issues when they occur expectedly or unexpectedly. There are very important and fundamental steps to get the team accustomed to the new environment. Storming is the next stage. By this phase, the team members have probably had a chance to get to know each other pretty well. They're clear on their own rules and responsibilities and that of their counterparts as well. They're fully aware of the project objectives, the timelines, the budget, some risks, and so on. But at this stage, some things still may not have been formalized. For instance, how the decisions about the project are made. Who makes those decisions? Who endorses them and approves them? This is the stage when the team gets to storm into the project to understand everything in a better way. Norming is the next stage. By this phase, the team has been working together for some time. They all know each other very well. They have a lot more clarity on the scope of the project and the goal of the project and all the commitments that have been made for the project on their behalf. The project manager can start optimizing them well. This is the stage where the project manager starts getting to drive the team towards the goal. And that leads to performing, which is the final stage of team development. They're collaborating and working with each other like a well-oiled machine. Here, the team is almost in an autopilot mode. They all are performing at their highest level of potential. A little bit of motivation from the project manager will ensure that the team does everything needed for the success of the project. So these are the 4 important stages of team development. Once you understand the 4 stages of team development and also understand the unique dynamics within your team, it becomes easier for you as the project manager to understand what it takes to get the team moving into the performing stage of the project. The project manager needs to keep the team motivated at all times to get the best output from each team member, which is absolutely critical to the success of the project itself. The project is the common goal which binds all the team members together. They must feel the pride and joy as the tasks are completed and the project shows progress. And they must also feel the urgency to handle any risks or issues which may spring up during the execution of the project. This camaraderie elevates the team's motivation and their zeal to contribute at their highest level. If the project manager is able to achieve this kind of team cohesiveness, the team will accomplish all their project goals in the most efficient way. The team must always remember the end goal of the project. There will be multiple diversions as the project moves forward in the form of risks, issues, etc. And it's the project manager's responsibility to keep the team focused towards the goal at all times. The project manager not only facilitates the activities of the project, but also tracks the performance of individual contributors. The project manager must recognize the best performers. A note of appreciation always goes a long way in motivating the team. And as touched upon earlier, the project manager must also keep track of the underperformers. Once the project manager understands each team member's contribution, he or she can provide them all the help and support they need to start performing at their peak level. And let's not forget, the team is comprised of team members, and these team members, as humans, have certain needs. Let's now understand the needs of the team. Let's start with physiological needs. These are some fundamental needs which are tied to every team member's expertise, their skill sets, their interests, and other aspects of their personal performance. These qualities in team members do not change overnight, so these needs almost always remain a constant throughout the project. The project manager needs to be aware of these aspects of each team member and must strive to align the assignment of each project member to their individual interest and temperament. And in some cases, the project manager will actually recognize potential in the team members which they themselves are not aware of yet. The project manager must harness this hidden potential and help the team member to develop it. For example, if someone in the team has a good eye for details, then that person can be a good reviewer. The safety needs of the team depend on the technology they work on and how safe they are concerning changing environments in the project environment. These needs may be related to environmental safety or another type of safety and security measures like cybercrime, hacking, computer viruses, etc. The risks also play a very important role in this aspect. Next is the need to belong and be an integral part of the team. The more the team feels they belong to the project and the team, the more efficient they will be in contributing to the project's success. The more ownership and commitment they will have towards the project. Motivating the team helps in improving the feeling of belonging. Esteem of each team member and the group as a whole is driven by how much of importance is given to the team in recognition of their hard work. The team should feel that their work is appreciated, which gives them a better self-esteem. And this is critical to making them more confident in contributing to the success of the project. Self-realization is more of a psychological need. It fulfills the desire of each team member to attain mastery of their craft. The work that they have done on the project must also fulfill their desire for creativity, personal development, career growth, and so on. Motivation from the project sponsors and the project manager helps here as well. And self-sustaining is the topmost layer in the needs and team management pyramid. This is when the team is highly motivated and focused. They get a better sense of risk assessment and management. They're highly efficient and self-sufficient. In other words, in this stage, the team is executing at the peak performance level and are almost in an autopilot mode. They know the importance of the work, the schedules, the costs, etc., and they perform without a major push from the management. This is the level every project manager dreams to achieve for their teams. And these are the critical layers of the pyramid for successful project teams. Let's talk about another important topic now, Johari window. In every project, there are some known aspects and there are some unknown aspects. It's essential that the project manager understands what are the situations that may put the project manager in an uncomfortable position. These are referred to the 4 doors of the Johari window. The first one is the open door. This means whatever the project manager knows, the entire team also knows. These are the objectives, the vision, mission, etc. The second door is the hidden door. These are some facts that the project manager knows, but it may not be well known to the team. For instance, some of these strategic facts or some key financial aspects of the project or team members is known to the project manager, but not the entire team. It's desirable for the project manager and the entire organization to be as transparent as possible, but of course, there are some factors that may not be suitable for open discussion. For example, the pay grade of each team member on the project. This is not a major issue usually. The third door is the unknown door. These are some things or facts that neither the team project manager nor the team knows about. These issues may actually become the biggest risks and endanger the outcome of the project. But not much can be done about these, well, because no one knows about them. The only thing that the project manager and the team can really do is to rely on their experience and be vigilant about these unknowns. And moreover, they need to be ready to tackle these unknown issues as soon as they manifest themselves. And the fourth and last door is the blind door. The project manager does not know these aspects, but everyone in the team knows this. This is a tricky situation for the project manager. Imagine that the project is slipping in the schedule. Everyone in the team knows about this, but not the project manager. These type of issues are sure to derail the project. So it's absolutely essential for the project manager to be on top of everything and be in sync with his or her team. The blind door is what the project manager has to be extremely careful about. Once you are aware of these situations, you can better equip yourself to react to them in a more responsive and proactive manner. Being aware of what particular situation you are in is a huge step forward in trying to solve most of the project management issues. That brings us to the end of this module. Let's quickly recap what you learned. In a nutshell, in this module you went through a number of software project team related topics. The team is the most important asset of the project manager throughout the project lifecycle. In this module, you learned the importance of teamwork. Then you learned about different team dynamics that you may have to deal with in a software or IT project. You learned about how to motivate your team and help them attain their peak performance levels. And you also understood some standard team management frameworks like the need pyramid and the Johari window. Hello and welcome to this module, Software Project Quality Assurance. Software quality assurance is another critical step or phase which must be implemented and completed diligently to ensure the quality and stability of the final product or service. These steps must be completed before the software product goes out to the market. This is the last chance for the project manager and the project team to capture and fix the issues before the software becomes an official product. We will go through the nuances of software quality assurance and testing phases of the software in this module. In this module, we will start with the basics of quality assurance process. This will lay the foundation for subsequent discussion about QA and testing processes. Next, you will understand how testing is performed. The QA process is made of several activities itself. First comes the test plan and then executing the tests themselves. You will then understand how the test cases are executed. Next, you will learn about the different types of testing which are prevalent in most software projects and why we need them. And we will conclude this module with the discussion on the defect collection and fixing. Let's start by understanding what software testing is. There are 6 facts about testing that you need to be aware of. Testing is nothing but checking the conformance to requirements. Meaning, as part of the QA process, the team should review if all the requirements are incorporated into the software that the team has built. This conformance should be evaluated for both positive and negative actions and outcomes. For example, if the user is expected to type in only numbers in a box meant to capture the zip code in a software, the testing should also check what happens if someone keys in alphabets. Next, testing needs to be comprehensive. If you don't test a specific functionality or a scenario, then there is a possibility that the untested functionality may not work. That being said, there may be some use cases which may be considered out of scope, and the team may decide not to test these out of scope features. Another fact about testing is that it is not meant to make the software perfect. As we discussed earlier, testing only checks the in-scope features. The out-of-scope features may have bugs, but these are considered acceptable within the specifications. Next is the quality of the final product is directly proportional to the amount of testing the software has been put through. That is why well-tested software is of high quality. Testing and reviews are 2 essential components of the software product lifecycle. The review is essential at every stage of the product, but testing is usually performed at the end of a product lifecycle. Fixing a bug during testing is more expensive than finding a defect during a review. Another important perspective on testing is that there is no definitive end to testing. The more you test, the more defects you'll find. It's a trade-off that you need to determine: cost and schedule and quality that you logically end testing. Okay, so now you are familiar with the testing processes and their importance. It's now time to get into the nitty-gritty details and understand how software testing is actually executed. Before starting the testing phase, a test plan has to be drafted. The test plan is a document that gives the overall structure to the testing activities of software or IT project. Very similar to the overall project plan, the test plan also has a start and end date for the testing phase. It'll have details as to what types of testing will be carried out by the testing team, the sequence of testing tasks, and their relative priorities. The dependencies of each test case will also be called out. For instance, most test cases will need the source code to be written and available so that the test engineers can execute their test. Another example could be that a test case may need some test data to be generated for a meaningful test to be performed. The test plan also lays out the scope of the testing regarding what components of the system will be tested and which ones will be considered out of scope. As we discussed earlier, there may be certain test cases which could be considered outside the scope of the project. Or some test cases may not be feasible to be executed because of external dependencies. For example, say if a partner's APIs are unavailable. Some of the components may not be ready at the time of testing, or the actual customer environment may be needed to execute certain test cases. All these will have to be documented in the test plan. And finally, the test plan has to be reviewed and approved by authorized team members so that it becomes a valid document to be referred to by everyone. This is an important step because this review and approval process ensures that the test phase has gone through a thorough verification and checks and has been accepted after this due diligence. Secondly, everyone in the hierarchy is aware of the test plan and the adequacy of it. We spoke about the importance of testing and what a test plan is. Now let's see what test cases are. Test cases are a small group of test steps that a software test engineer executes to test the software and verify whether the software product or service behaves the way it should. Test cases have a unique identification number, and they check either a single or a group of functionalities or requirements. Every test case has a corresponding requirement to be tested, and every requirement has associated test cases which verifies the functionality against the particular requirement. This reference is called bidirectional traceability. This ensures that one can easily trace from a test case to a requirement, or the other way around, to know which requirement has been tested and how. This is an important component and comes in really handy later on in the software lifecycle when we get into defects. Test cases have certain preconditions which need to be satisfied before the test case can be executed. For example, if there is a form to be filled with certain data or certain functionality has to kick off to generate specific data, then without the presence of the data, one cannot test the functionality. The testing can't be done randomly. It needs to follow a specific sequence of testing. Otherwise, the dependency on the previous functionality may cause failures for the current functionality. For example, if you want to test the validity of the zip code for an address, unless you first fill the address details, you can't really test the validity of the zip code. Test cases also have an associated result, which basically tells you whether the expected result was achieved or not. And based on these results, the software module is passed or failed accordingly. Now let's understand how test cases are actually executed. As we saw, the test plan provides the overall blueprint for all the testing activities to be carried out within a project. Hence, the testing team uses the test plan as a reference and runs the test cases on a software that is ready for testing. First of all, one needs to test the new functionality that has been added afresh to see if it's working as designed. This is to test the newly added feature without any dependency on any other functionality. The test cases may also have a set of tests which verify whether the previously tested component of the software is still working as per the requirement after a certain additional component is added. These are called regression test cases. After the regression test cases are run, then the normal test cases are run to see if the new components added are working as per the requirement. Usually, at least 2 regression tests are done for any software testing phase. This is to ensure that the previously verified components work for the first time and again after few defects are fixed. This ensures neither development of new code nor repairing of old code breaks the previously working component of the software. As you now know the importance of testing, test plan, and the actual test cases, let's focus on the different types of testing. The first component of testing is unit testing. Unit testing is typically done by the software developers that develop the component. This is the first level of testing. The unit testing checks individual components that are developed, and it doesn't depend on any other part of the software components. The next level of testing is the integration testing. This is to test the integration of two or more of the modules or components to see how the interaction is working as per the requirements. Although parts work individually well, there may be complications when they have to interact with other components. Integration testing is sometimes referred to as system testing as well. We already discussed regression testing. This type of testing verifies whether the newly developed component is working well with the previously working software modules. And there's also something called smoke testing. This is usually the final part of testing to ensure that the software is ready for final build and release to the end customer. This type of testing has a sample of a few critical test cases, which are typically the usual test cases every user will go through. For instance, logging into the system, browsing the main screens of the software, and so on. So far, you have learned about the various components of the testing phase. After a stringent testing phase, it is inevitable that you will find certain test cases that don't pass. Or in other words, some functionality or feature may not work as per the specification. These are called bugs or defects. A programmer, while designing and building the software, can make mistakes or errors. These mistakes or errors mean that there are flaws in the software. These are called defects. When an actual result deviates from the expected result while testing a software application or product, then it results in a defect. Defects should always be recorded and tracked through a tool generally called the defect tracking tool. Every defect, irrespective of its magnitude, has to be recorded and prioritized. Just like risks, each defect also has a potential impact on the user. It also has a likelihood of an end user encountering this bug while working with the product or service. You can also attach the magnitude of work needed to be done to fix the defect. Based on these criteria, the team needs to prioritize the bugs in order of their severity and likelihood. According to the deadlines and time constraints, the team may choose to fix only highly visible and impactful defects. Because sometimes if the timelines are short, one may need to take a call whether or not to fix a defect that is only cosmetic and won't impact any feature. There may be a situation that you may not want to fix all the defects. For prioritization and analysis purposes, you must assign some categories to the defect just like we did for risk assessment. For instance, the severity of the defect can be assigned in categories such as critical, major, and minor. Or you can use something similar, but it's recommended that you use between 3 to 5 categories to classify your defects. This will keep things streamlined and efficient. The classification is done so that the priorities of fixing them can be based on a certain logic. As the team prioritizes and fixes these defects, care must be taken that when a defect is fixed, the fix doesn't produce another defect. This is where the regression testing comes into the picture and verify that the system is working as expected even after the bug fixes. What we just talked about was more related to functional defects. There are other types of defects that a team may need to test for. For instance, there are performance and scalability defects which verify the responsiveness of the system and the capability of the system to handle more load as it gains more traction. Normally, during the initial stages of the project, the performance levels are also given as requirements. These are not only the specifications of the correct functionality, but they also indicate how efficiently it should work. For example, if a certain activity takes 10 seconds to execute, the performance specification may expect it to work in 5 seconds. So just checking whether the functionality works is not enough. This testing should also check if it works within 5 seconds. Other types of defects could be related to user experiences, cosmetic bugs, and so on. That brings us to the end of this module. Let's recap what you learned. In this module, we started with the basics of quality assurance process. Next, you learned how testing is performed and how the test cases are executed. Next, you learned about the different types of testing carried out during software or IT projects. Then we concluded the module with the discussion on the defect collection and fixing. Hello and welcome to this module of Art of Software Project Management for Software Engineers. Here we're going to talk about software project closure. After all the hard work that goes into a project, all the development and testing activities, all the review activities, the final phase of the project is closure and handing over the final product or service to the stakeholders. In this module, you will understand how to logically close a software project. Project closure is the last stage of a software project management. You may wonder why we need to formally close a project, and this is precisely what we will discuss in this module. You will start with the activities that are part of the project closure phase. These set of activities usually are pretty straightforward, but they're crucial in the software project management environment. We will then move to understand what a project post-mortem is, and you will understand why this is done. We will then look at what a project archival is and how it is done. As you may have already realized, the project closure has to start when all the project deliverables are complete. So the first step here is to check whether all the committed activities of the project are completed and the deliverables are ready to be handed over to the end users. As project closure is the last phase, ideally nothing should be left out to be implemented. The closure is the final and formal phase, which involves handing over the final tested and approved deliverable. The next step in this phase is to release all the resources. When we say resources, it includes human resources, software, hardware resources as well. This is important because resources are highly critical for any project. Some projects may be waiting for these resources to be released, and they may be part of their project plan. This applies to both human resources that are team members or the hardware resources like servers, test environments, development environments, printers, and so on. Next is to archive the product documentation so that it's available to other projects. Archival is not limited to only documents. It can be implemented for other artifacts like code, architecture, test cases, test plans, and anything that can be reused as it is or in a modified state. This way, at an organizational level, you can reuse the artifacts from previous projects and get a jump start on new projects. This is not only more efficient, but it also reduces errors and omissions because all the lessons learned from the previous project will be incorporated into the processes for the new project. One can always use these components in another project without starting from scratch. But care must be taken to make sure whether the reuse is legally valid. In some instances, the artifacts which are produced may actually belong to a particular customer or client. And since they are the legal owners of the intellectual property, you may not have the right permissions to reuse them for other clients or projects. So in those kind of cases, the reuse is not permitted. And the last step in this phase is the postmortem. This is where the discussion happens to understand the project and look back at it. Out of these discussions, many nuggets are found, like what went well and what not so much. Let's look into the details of each of these activities. Usually, the project manager checks the project contract to check if all the deliverables mentioned as part of the contract have been delivered or not. It's essential that all the committed deliverables are completed for a project to move to the closure stage. For completing this as a formal process, a sign-off is necessary. The project manager must obtain this formal sign-off from the project sponsor. It's also necessary that all the relevant documentation is submitted as part of the project delivery. The project manager also verifies all the contractual obligations concerning the project completion to make sure if they are complied with. Part of this process may involve some of the relevant documentation or user licenses procured specifically for the project may have to be surrendered. The software project releases all the resources used during the project. These can be human resources, software resources, and hardware resources. Usually, specific software or hardware resources are made available for a software or IT project. Once the project is over, they may or may not be used for other projects due to copyright and information protection rules. The project manager should be aware of these and release the resources as soon as the project ends. The human resources, of course, have to be released so that they can be allocated to other projects. Sometimes there may also be some financials that may have to be closed at project closure. Project archival is an important activity. During this activity, the project manager documents all the learnings, best practices in terms of what worked and what didn't, and any other project-related documentation so that they can be used later. Some contracts may make it mandatory to preserve some artifacts produced during the course of the project for a specific duration after the completion of the project. The project manager should be aware of these contractual obligations and should implement them accordingly. An important activity for the project manager is to celebrate the success of the project by rewarding the project teams appropriately or by throwing a party. Project postmortem is the final activity in the project closure. The project manager has to sit with the entire team to identify what went well and what didn't go so well. These discussions and findings must be documented and distributed among the team members. This gives an opportunity for every member of the project to speak up about the project in an open forum. There are generally a lot of learnings which originate from a project. These learnings may be technical or related to soft skills, strategies, and so on. It is best to execute this postmortem as soon as the project ends, while the memories of the project activities are fresh in everybody's minds. It's also very important for the project manager to encourage open and honest discussions without the fear of any repercussions. The project manager should create a knowledge base of these learnings so that they are useful for similar other future projects. This is also an opportunity for the project manager to give feedback to the entire team and also individually to the team members about their contributions to the project. This is a two-way discussion. The project manager also takes feedback from the team members about how well the project was managed. The project manager also should retrospect a self-review to document what was handled well and what was not, so that the next project can be executed using all the improvement opportunities learned from this project. This wraps up the module on project closure. Let's quickly recap what you learned. You got familiar with project closure, which is the last stage of a software project management. You also got a good understanding of the activities that are part of the project closure phase. And finally, we discussed project post-mortem and its importance. This also wraps up this course on the art of project management for software and IT engineers. In this course, you got an in-depth look at how you can elevate your career and manage software and IT projects. We hope you find this information useful in your software and IT projects. And we also hope you had as much fun learning about software and IT project management as we had putting together this course for you. Let's stay in touch. You can connect with us directly via social channels like LinkedIn or Twitter, or you can also email us directly. We'll be glad to help you out in any way that we can. Please don't forget to leave a review for this course. It'll help us and moreover other learners. And last but not least, please do check out other top-rated courses that we are offering. There are many special offers available for you in the last bonus lecture of this course. Please consider it as a token of appreciation for our current students. Thank you.